The 50-horsepower Samson gas engine featured here is experiencing its first run in more than a century. Built by the Samson Iron Works of Stockton, California, this massive two-cylinder vertical engine represents one of the company's largest power units. It originally operated in a mining facility in Arizona, providing reliable mechanical power until the site shut down in the late 1910s. Designed for durability, the engine features heavy cast-iron construction, large flywheels, low-speed operation, and an early gas ignition system typical of industrial engines of that era. Having last run over 100 years ago, its return to operation is a rare event. It is believed to be the only surviving Samson engine of this size and configuration, making it an exceptional historical artifact. The 1913 Sandy McManus Sandow 1 3/4 horsepower engine was built by the Waterlue Gasoline Engine Company of Waterlue, Iowa, and marketed through Sandy McManus Inc., a short-lived distributor established in 1912. This model represents one of the private label engines Waterlue produced for various regional dealers during the early 1910s. The Sandow operates on a classic hit-and-miss governing system, in which the governor holds the exhaust valve open to interrupt combustion whenever the engine exceeds its set running speed. It is an air-cooled design, making it simpler and lighter than its hopper-cooled counterparts. Ignition is provided by a mechanical igniter powered by a battery and coil, typical of small Waterlue-built engines of the era. While exact dimensions vary, comparable Waterlue engines in the 1.5 horsepower class used a 3.5-inch bore and 5-inch stroke, giving a reliable and smooth running performance for farm and light industrial duties. The antique gas engine, a 1917 John Smythe Faultless 1 3/4 horsepower engine, built by the Waterlue Gas Engine Company of Waterlue, Iowa. John Smythe & Company sold these engines under the Faultless name through catalog distribution, while Waterlue supplied the mechanical design and manufacturing. This model uses a classic hit-and-miss governor, which controls speed by allowing the exhaust valve to remain open when the engine exceeds its set RPM. Ignition is typically via low-tension igniter, and fuel is delivered through a simple mixer. The engine features water hopper cooling, a heavy cast-iron flywheel pair, and a robust open crank layout, common to small farm engines of the period. Engines like this powered cream separators, small pumps, light machinery, and general homestead equipment in early rural America. The 1948 Gibson tractor with its dependable Wisconsin engine evokes a strong sense of post-war rural memory. It represents a time when small farms relied on simple, hard-working machines to power daily life. The soft rumble of the air-cooled Wisconsin engine, the smell of fresh earth, and the feel of steel controls bring back images of early mornings in the fields. This tractor recalls an era when innovation met necessity, helping families modernize their farms while preserving hands-on craftsmanship and tradition. It stands as a living reminder of mid-century agricultural heritage. The engine shown is a 1920D 570, built in the first year of production for the 10-horsepower model. This early example represents the beginning of the line's development and retains many of its original design characteristics. It was imported to the Scrivelsby estate in Lincolnshire, England, where it served as a reliable power source for estate workshops. The engine drove a range of machinery through a traditional line shaft system, providing mechanical energy for woodworking, repairs, and general maintenance tasks. Its long operational life reflects both its durable construction and the importance of stationary engines in early 20th century industrial work. The engine shown is a large vintage Fairbanks Morse stationary power unit, likely similar to the Model 32 series commonly used in industrial settings during the early to mid-20th century. These engines were built as heavy-duty, low-RPM workhorses capable of delivering reliable power for sawmills, generators, and remote industrial operations. Typical Fairbanks Morse engines of this type used a two-stroke semi-diesel or diesel cycle with massive flywheels to maintain smooth operation. Their robust construction made them ideal for continuous service in locations without electric infrastructure, and many remain in museums today as running examples of early industrial power technology. Impressive startup of a giant Sulzer diesel engine, weighing an astonishing 15 tons and rated at 100 horsepower. Built for heavy industrial applications, this stationary engine demonstrates Sulzer's renowned engineering and durability. The startup process begins with careful pre-lubrication of the cylinders, ensuring smooth operation. As the engine fires, the massive flywheel begins to rotate steadily, and the characteristic deep, rhythmic exhaust pulses resonate through the building. These engines were commonly used in factories, power plants, and marine applications, where reliable, continuous power was essential. Observing the synchronized motion of pistons and connecting rods highlights the precision of early 20th century engineering. This 15-ton Sulzer engine is a testament to the era of monumental diesel technology, combining raw mechanical power with meticulous craftsmanship. Webster magneto-equipped stationary engines were widely used in early industrial and agricultural applications during the late 1800s and early 1900s. Many of these engines, including inverted types and German station arm motor or stand motor designs, were produced between 1895 and 1930, a period when slow-running single-cylinder machines powered pumps, generators, and workshop tools. These engines often featured heavy cast-iron frames, hidden misgovernors, and reliable Webster ignition systems. Inverted engines, with their crankshaft above the cylinder, also appeared around 1910 to 1925, offering improved visibility and easier maintenance. Together, they represent an important era in early internal combustion technology. The Deutz MAH711 is a classic stationary diesel engine produced by Deutz AG, one of Germany's most influential early engine manufacturers. Belonging to the MAH series, Motor MIT Stehendem Zylinder, Liegende Kurbelwelle und Haube. The model features a vertical cylinder paired with a horizontal crankshaft, a configuration well suited for durability and continuous operation. The MAH711 is a single-cylinder water-cooled stand motor, often built as a Verdampfer motor, evaporator-cooled engine, a typical cooling method for engines from the early to mid-20th century. Engines of this type were widely used for agricultural machinery, workshop equipment, pumps, and small generator sets, valued for their reliable low-speed torque and straightforward mechanical design. The Lister 6/1CS diesel engine shown here is a classic slow-speed stationary power plant, widely admired for its reliability and smooth operation. Rated at 6 horsepower at 650 revolutions per minute, the 6/1CS features a single cylinder, compression ignition design with a distinctive flywheel layout and hand crank starting. These engines were commonly used in rural power generation, water pumping, and small industrial applications throughout the mid-20th century. In this setup, the engine eventually drove the small generator visible in the background, providing steady electrical output at low fuel consumption. The 6/1's characteristic rhythmic exhaust note and dependable running made it a favorite among off-grid users and engine enthusiasts. The engine 1950s Lister FR4, a single-cylinder, air-cooled diesel designed by R.A. Lister & Company for reliable light industrial and agricultural use. Known for its smooth running and efficient fuel consumption, the FR4 was part of Lister's well-regarded FR series introduced after World War II. In this setup, the engine is coupled to an ECC 3.5 kVA generator producing 40 volts DC, a configuration commonly used for battery charging, workshop equipment, or small off-grid power systems. Engines of this type were valued for their easy starting, long service life, and ability to operate continuously under load, making them a dependable power source in remote locations. The Lister FR4 is a four-cylinder, water-cooled diesel engine produced by R.A. Lister & Company in the mid-20th century. Known for its durability and smooth running, the FR4 was widely used for generators, pumps, and industrial equipment. This rebuilt unit features a refreshed fuel system, overhauled injectors, and restored cooling components to bring it back to reliable operating condition. With a displacement of around 3 liters and a reputation for steady, low RPM torque, the FR4 delivers dependable power for continuous duty applications. Its cast-iron construction, efficient combustion design, and robust mechanical governor make it a long-lasting and easily serviceable classic Lister engine. Represents one of the classic 8 HP models produced during the mid-20th century, with most examples manufactured between the late 1940s and early 1960s. Built with remarkable robustness, these engines became famous across Asia and Africa for their long service life and simple, repairable construction. The engine is a vertical, single-cylinder, water-cooled, 4-stroke diesel using direct injection, a design that delivers strong, low RPM torque and excellent fuel efficiency. Its cast-iron build, heavy flywheel, and slow-running characteristics allowed it to operate reliably under the harsh conditions of agricultural work. Rated at around 8 horsepower, the engine was primarily used for driving irrigation pumps, flour mills, small generators, and other farm machinery in areas lacking dependable electricity. Starting was done manually by rotating the large flywheel until compression built up, a method that required skill but ensured operation without batteries or external starters. Field Marshal engines were widely exported, and many units assembled under license in South Asia became known locally as Kala engines or Desi engines. Their durability and straightforward mechanics have kept them in active service for decades. The Rolls-Royce Viper ASV8, also known as the Viper Mk102, is a compact single-spool turbojet engine widely used in early jet trainers and light aircraft. This engine features a centrifugal flow compressor, a robust combustion chamber, and a simple turbine layout that provides reliable thrust in a lightweight package. Starting the Viper with a hand crank system involves manually spinning the compressor through an external mechanical drive until sufficient rotational speed is achieved for fuel ignition. Once fuel flow and ignition are introduced, the engine quickly accelerates to idle RPM. Its rugged design, straightforward starting procedure, and consistent performance made the Viper Mk102 a trusted power plant for many aviation applications. The V12 Panzer motor, most commonly represented by the Maybach HL120 and HL230 series, was produced in Germany during the late 1930s and throughout World War II. The Maybach HL120, introduced in 1936, was a 11.9-liter water-cooled V12 gasoline engine, delivering around 300 phosphorus monosulfide, powering early and mid-war tanks such as the Panzer III and Panzer IV. In 1942, Maybach introduced the larger HL230, a 23-liter V12 engine producing up to 700 phosphorus monosulfide, used in heavy armored vehicles like the Panther and Tiger I. These engines provided strong, low RPM torque and reliable performance, making them essential to the mobility and battlefield effectiveness of German armored units during the war. The 1963 Bergen Diesel RTGB3 represents one of the company's first four-stroke diesel engine designs, marking an important technological step in Norwegian marine and industrial power. This robust three-cylinder engine delivers 280 horsepower at 600 revolutions per minute, about 205 kilowatts, providing strong, steady torque ideal for continuous duty operation. Each cylinder has a 250 mm bore and 360 mm stroke, giving a displacement of 17.66 liters per cylinder for a total of roughly 53 liters. Weighing 500 kilograms, the RTGB3 is built for durability, reliability, and long service life. Engines of this era are admired today for their heavy engineering, distinctive sound, and enduring mechanical character. A traditional sugarcane crusher used for making jaggery is a rugged, mechanically simple machine designed to extract juice from freshly cut sugarcane stalks, commonly found in rural regions of India, Pakistan, Nepal, and parts of Southeast Asia. These crushers continue to play an essential role in small-scale jaggery production. The machine typically features a three-roller arrangement, with the rollers positioned vertically in a sturdy cast-iron frame. This configuration allows the sugarcane to be fed manually from the top, passing through progressively tighter gaps as the rollers rotate, ensuring maximum extraction of juice. Most traditional units rely on an external power source, such as a single-cylinder diesel engine, a slow-speed stationary engine, or sometimes even oxen or bullocks in older setups. The diesel-powered system is now the most common, providing a reliable and continuous rotation of the heavy-duty rollers. These rollers are ribbed or grooved to grip the cane effectively and crush it with significant pressure. The extracted juice flows down a channel into a collection pan, where it is filtered before being transferred to large boiling vessels to begin the jaggery making process. The frame of the crusher is generally built from cast iron or heavy steel to withstand constant vibration and high torque. Simple bearings and mechanical linkages make maintenance relatively easy, even in remote villages. Lubrication, tightening of belts, and occasional roller alignment are typically the only routine tasks needed to keep the machine running smoothly. Despite its simplicity, this traditional crusher remains remarkably efficient for small farms and cottage-scale jaggery producers. What makes these machines valuable is their durability and adaptability. They can operate for long hours during the sugarcane season and handle variable cane sizes without complex adjustments. Their straightforward design allows local mechanics to repair or fabricate parts, ensuring long-term usability. Even as modern hydraulic and electric crushers emerge, the traditional three-roller unit continues to be trusted for its toughness, low operational cost, and suitability for rural jaggery production. The 1928 Hart-Parr 18-36 tractor represents one of the most important machines produced during the late 1920s, a period when Hart-Parr was helping shape the early tractor industry. Built between 1926 and 1930, the 18-36 used a large two-cylinder engine designed for steady torque at low RPM, making it ideal for demanding belt work. Because of its strong belt pulley power, the tractor was commonly used to operate stationary equipment, such as rock crushers, threshers, sawmills, and grain grinders. Farmers valued it for reliability and the ability to replace steam engines in heavy tasks. At shows like the Edgar Steam and Gas Engine Show in Wisconsin, a 1928 Hart-Parr 18-36 is often demonstrated driving a rock crusher, highlighting its original purpose and historical significance. The SFV402, built by Société Française de Vierzon between 1952 and 1957, is one of France's most iconic vintage tractors. Often called the Frenchland's Bulldog, it features a large single-cylinder semi-diesel engine known for its deep exhaust note and strong low-speed torque. Designed for reliability on small farms, the 402 worked in plowing, hauling, and threshing. Its simple hot bulb-style design made it easy to maintain, and today it remains a favorite among collectors for its rugged character and distinctive starting procedure. The Delan-Belleville hot bulb semi-diesel engine is a robust early internal combustion design built for steady industrial and marine use. It operates with a heated vaporizing bulb, where fuel is ignited by contact with the red-hot chamber rather than high compression. This simple and reliable system allows the engine to run on heavy oils and deliver strong, low-speed torque. Known for durability and smooth rhythm, it served in pumps, generators, and small boats throughout the early to mid-20th century. The Bishoff Wilbis 1914 is a small, early 20th century model engine produced by Bishoff Werk in Germany. Manufactured in 1914, it represents one of the delicate and precise engines of its era, primarily designed for demonstration, experimental purposes, or to power small machinery. The engine features a bore of 50 mm and a stroke of 80 mm, delivering approximately 1 PS at 200 revolutions per minute. Weighing around 36 kilograms, it is compact and robust for its size, reflecting the high craftsmanship typical of early model motors. These engines were often used to drive miniature generators, small machine tools, or as display units in technical exhibitions, demonstrating internal combustion principles. The Wilbis motor belongs to the atmospheric or non-compression explosion type, a design common before the widespread adoption of high-efficiency compression engines. Today, the Bishoff Wilbis 1914 POWER13 is considered a rare collector's item, valued for its historical significance, engineering design, and contribution to early engine experimentation in the pre-World War I period.